number 7 is asking us to identify the scale factor, which means that we are assuming that they're similar, which is what dilation means. So because this dilation is going to imply similarity, so do you see that they're oriented differently? So what I'm going to do is I'm just going to select this triangle and rotate it so that they're oriented the same way. It just makes it easier to identify what's going on. Do you see how here you have the 30-degree angle right here, and then here you have the 30-degree angle. And then up here you have the 60-degree angle, and here you have the 60-degree angle. So that just makes it a little bit easier to work with, okay? So now the other thing I'm going to do, and I think you should do this as well, is I'm just going to draw the reference triangle, okay? We know by now, we know the reference triangle values very well. So if you know that this is 1, 2, and square root of 3, we can look at this triangle right here. And what is it that enabled us to get from here, square root of 3, to here? Do you see that if you multiply this by the square root of 5, that gets you here? Okay? So if that's true, then I'm just going to draw this. So the scale factor to get from the reference triangle to here is square root of 5, which means that this dimension right here would have to be square root of 5. This dimension here would be 2 times the square root of 5. Do you see that? Because everything, all of these dimensions right here are being multiplied by the square root of 5. So this hypotenuse right here is going to be 2 times the square root of 5 because of the scale factor. Now, what we want to know really though is what is the scale factor that gets us from here to here. So that ends up being really easy then, because you can just ask yourself, okay, what factor lets us get from here to here? Well, what do you have to multiply this by to get to 14 times the square root of 5? You can see that easily. It's 7. And that is why C is the correct answer. Go, Mr. Parrish.